Okay, so our next problem says write each expression in factored form. I'm looking at two trinomials here. First thing, whenever I'm factoring, I always want to ask myself, do I see the difference of perfect squares? Of course, they're trinomials, so it's not the difference of perfect squares, right? I don't see any GCF because there's nothing in common in all three, right? Nothing that factors out of all three. And so I move into the fact that I see a trinomial, so I can break this up into two blank binomials that I'm going to fill in. So I break it up into my two blank binomials because that's how I factor a trinomial. And I start off with the first term, x squared. Well, that's easy to break up into just x times x. Now, I want to break up the number, and I use my inners and my outers as like terms to get my middle. So first, let's get my numbers. Let's break up 24. 24 can be broken up into factors. Let's start off with 1 times 24, 2 times 12, 3 goes into 24 times 8, 4 goes into 24 times 6. The only other number in between 4 and 6 is 5. So since I've connected, there aren't any other factors. And so what I want to do now is I want to put one of those numbers here and here, and then I'm going to multiply my inners and my outers, and the sum of those like terms should add up to negative 5x. So out of the numbers that I have here, which one, adding or subtracting, will get me a negative 5? It doesn't matter what I do, add or subtract to 1 and 24, I'm never going to get a negative 5. 2 and 12, add or subtract, will never get me a negative 5. 3 and 8 will give me a negative 5 if I subtract them properly. 4 and 6 won't. So 3 and 8 are the numbers I'm working with. So I put a 3 here, I put an 8 here. My 3 times my x is 3x. I don't have any numbers in front of the x's, so it's just going to be whatever the coefficients are. 8 times x is going to be 8x. And now I look at my inners and outers and decide what signs should I put on them to make this work. So if I know I'm going to negative 5, right? So adding is going to get me an 11, so it's got to be subtraction somewhere. So if I put a negative here and a positive here, that's going to give me 5, because positive 8 and negative 3 is 5. I don't want 5, I want negative 5. So that's not going to work. What if I switch them and I put the positive here and the negative here? Well, now I have negative 8 and positive 3, which will give me a negative 5. And so my inners will add up to my middle, negative 3x. My outers, positive 3x, negative 8x, will add up to my middle. And so the inners came from here, positive. The outers came from here, negative. And those are my factors. They didn't ask me to do anything else other than factor, so I'm done. I'll move on to the next problem. Again, not the difference of perfect squares, it's a trinomial. I don't see anything that I can factor out of every single term, so there is no GCF. And so I break it up into two blank parenthesis sets for my binomials. X squared, I can break up into x times x. I'm going to look at the 32. I'll get the middle in a minute. So the 32, 1 times 32 is an option. 2 times 16 is an option. 3 doesn't go into 32. 4 does, times 8. In between 4 and 8 are 5, 6, and 7. 5 doesn't go into 32. 6 doesn't go into 32, and neither does 7, so I'm done. So now I need a pair of numbers that can go here and here, here and here. Since I'm multiplying them just by x, I need to make these numbers can give me my 14. 1 and 32 certainly can't. 4 and 8, whether I add or subtract, I won't get 14. But 2 and 16, if I subtract, I might be able to get a 14 out of that. So those are my numbers, 2 and 16. My inners are 2x. My outers are 16x. And now I need signs that make this make sense. Well, I'm going to 14, which means I have to subtract something. My answer is positive, so I'm going to subtract the smaller number and make this one positive. 16 and negative 2 will give me a positive 14, so the inners came from here and the outers came from there. They didn't ask me to do anything else, so I factored and I'm done.